Good afternoon, this is Schweitzer, and we are looking to start a little more of a practice page on solution stoichiometry. This video here should be reviewed, but is kind of critical to truly understanding the stoichiometry of solutions. So this part's going to review some of the concentration stuff that we need to apply to it. So in this situation, we're just going to be looking at mixing solutions, and then the next part will be mixing solutions with chemical reactions. So, answering questions relative to dissolving substance in a solvent. So you want to try these things and then play the video through. Write out the dissolving equation. Okay, NaCl goes to Na plus Cl minus. If a solution has a concentration of 0.5 molar NaCl, what are the concentrations of these guys? Now we know that there's a long way of doing this, which is, well, we don't have a volume, so I can't figure out my moles. So I'm always kind of keeping an eye on this formula. But I don't have a volume, but I do know that if I have 0.5 molar NaCl, that if it's 0.5 times the number of these guys. 0.5 times 1 is, that means this guy is 0.5 molar. 0.5 times 1 is 0.5 molar for that guy as well. An example might be, let's say, 0.5 molar magnesium chloride. Well, then this magnesium would still be 0.5, but the chlorine would be 1 molar. Because when it breaks apart, it's showing right here, we get multiples of certain items, and therefore it increases. Alright, what do we got here? Okay, 0.75. Okay, so use your example here. Magnesium chloride goes to magnesium 2 plus Cl minus. There's two of those. Okay, what are the concentrations? Pause the video, try it out. 0.75 and 1.5. Again, this guy gets multiplied times 1, this guy gets multiplied times 2. For each of the following solutions, determine the concentration of each ion. Okay, so we're just doing some more of this stuff. Alright, pause the video, try it out. The aluminum is 0.75 molar, and the chloride, so that's 0.7 times 3. So 0.75, 2.25. Alright, 2.25 moles per liter. This guy times 3, so the magnesium ion is 0.75, and the phosphate ion is 0.5. Alright, and hopefully you're keeping up here. Alright, beaker to the right is representing 50 milliliters of 0.1 molar magnesium chloride solution. Wrote the picture. Draw a relative solution that's 50 milliliters of 0.2 molar magnesium chloride. Alright, so in the beaker to the right wants us to draw this, so all I'm going to do is same volume. It's going to be just two times that, twice as concentrated. So I'll do the negative equals the chloride ion, and the positive will equal the magnesium 2 plus ion. Being a little lazy here. Okay, what's the chloride ion in the 0.1 beaker? What's the concentration of the chloride ions in the 0.1 beaker? Well, it's going to be 0.1 times 2 is 0.2 moles per liter, and the chloride ions in 0.2 beakers, 0.2 times 2 is 0.4. Calculate the moles of the chloride in the 0.1 beaker, so it's going to be molarity equals moles per liter. Rearrange. Molarity times liters equals moles. Molarity is 0.2 times the volume of 0.05 liters equals, alright, so it's 0.2 times 0.05 equals 0.01. Alright, so this is going to be 0.01 moles. Without calculating how many moles of chloride ions are in the second beaker. Okay, so we know it's twice the concentration, so it should just be times 2 equals 0.002 moles. If you triple the concentration of your original solution, how many more moles would there be? Well, it would be 0.003. So we're seeing a linear relationship here. Obviously, in this situation, by whatever I do to this guy happens to this guy. That's called a linear relationship. Same with the volume. If I double this, if I multiply times 100, this would be times 100. That's a linear proportion. So, all right, next one. A 10 milliliter 0.1 molar solution of sodium chloride is mixed with 0.1 molar NaC, 10 milliliters, okay, of this guy. Okay, so before and after, so mixing two solutions. Take a moment, try this out. Now, I have 10 milliliters of this stuff right there, and I have 10 milliliters of, so it's the same concentration, same volume, two different substances. So you notice that the sodium is the one thing that's a little bit unique. The sodium's present in both items. So that would not be a dilution. Okay, dilution means all we're doing is adding solvent. So having one solution with content in it, substance, and all I'm going to do is add more solvent. The chloride is not present here, so the chloride's just going to be adding volume. No more chloride being added, and the nitrate's no more nitrate being added. So the nitrate and the chlorine are more like dilutions. And I'll approach them differently here. So you can take a moment and try this out. Pause it. So important. Okay, so before, this solution is 0.1 times 1 and 1, so that's 0.1 and 0.1, 0.1 and 0.1. Okay. Okay, because everything's just 0.1, 0.1, 0.1. Now, I'm going to go ahead and do the dilutions right away. Now, the dilutions will be this guy and this guy. Now, at that point, you could use the molarity formula for all this stuff. You have to understand the molarity formula, because if you don't understand that, you really don't understand what's going on here. So, let's get the moles of the sodium, the moles of the chlorine, and then we'll just dilute by a larger volume. So let's do the moles, which is molarity times liters equals moles. Molarity is 0.1. Volume is 0.01 liters. It's 0.001 moles. So that's the moles I have. That's not going to change. You need to just divide this by a larger volume. Larger volume would be now 20 milliliters, 0.02 liters. And we get our new volume. So 0.001 divided by 0.02 equals 0.05. So now you'll notice here I just 0.05. Now that's a long way, but the short way would be doing M1V1 equals M2V2. That's for a dilution. But you should note that I'm doubling my volume, so this guy just gets brought down to 0.05. That's half of that. Same thing goes for this guy, 0.05. Okay? This math here would be, this is 0.1, this is 50, this is 100, solve for this guy. And that would be half of it, which is 0.05. Okay, now the sodium is a little bit different. It's not a dilution. So now we gotta get the moles of 1, the moles of 2, add them together, and then divide those moles by the new volume. So go ahead and try this out. Pause the video. Alright, my moles are the same as everybody's. They're the 0.01. So this is the math for the moles. So this is going to be, let's get a different color here. This is 0.01. This is 0.01. excuse me, 0.02 divided by the new volume. 20 milliliters is the new volume, so 0.02, and 0.012 divided by 0.02 is just, so we got here. Okay, so our moles is actually 0.001. I mistake that. 0.01, 0.001, which is 0.002. And this, therefore, this is 0.1 molar. And that's my new concentration, 0.1 and 0.1. You'll note that we took 0.1 and dumped it into 0.1, so we stayed at 0.1. We didn't dilute it. We had two sources of moles, and they both came together. Let's try that same concept. If you didn't get through it all the first time, try it on this one. Okay, and make sure you can get yourself through it on your own. Pause the video. Alright, so now we have 10 milliliters of 0.1 molar, so this is going to be 0.1 and 0.1. 0.1 molar of 30 milliliters of this stuff. 1 and 0.1. So now we're adding them together of different volumes. So my dilution is going to be a little different. But I'm going to point out that the last one we did was 0.1 dumping into 0.1. So this should stay 0.1. And you can go through the same process we just did, but you should realize it's still 0.1. It doesn't matter. Let's take a moment and look at for the chloride ions. The chloride ions, I'm going to use this dilution formula. Same as this guy. You could do it this way, and I'd even prefer you do it this way. This is nuts and bolts of how it actually works. Get the moles divided by the new volume. New moles divided by new volume. Alright, so with that being said, let's just do this. M1V1 equals M2V2. M1 is, well, it's 0.1. 0.1, so I'm doing this guy. Okay, so it's 0.1. Initial volume is 10 milliliters. Ending concentration is unknown. Ending volume is 30 plus 10 is 40 milliliters. Alright, and then 0.1 times 10 divided by 40 equals 0.025. Alright, so X equals 0.025 moles per liter. So that one got diluted down quite a bit because we had an extra 30 milliliters added to it. 0.025. This one is, let's do the math on that first. So now we're going to take the 0.1, 30 milliliters equals unknown value, and then 40 milliliters. So this guy only got 10 added to it. So let's go ahead and do the math. 0.1 times 30, 0.1 times 30 divided by 40 equals 0.075. X equals 0.075. A little bit closer to the 0.1 because not as much was added to it. 0.075, and then that's it. Okay. Alright, so last one here before we shut down this first half of this page. So go ahead and try it on your own. Alright, so we got to pause the video. You should work your way through all of this. In the beaker to the right, draw 50 milliliter. Okay, so 50 milliliters. Now, here at 25, I went to 50. Same concentration though. So I'm going to just double this up. But I have the same number of stuff in here. No difference. Okay. It's half as concentrated. Hold on a second here. So I got double the volume, same concentration. So I need to have 2 more in here. Okay, same concentration, twice the volume. What is the concentration of the chloride ions in a 25 milliliter beaker? Well, chloride would be 0.1 times 2 is 0.2. The chloride ions in the 50 milliliter beaker, that's still 0.2. 0.1 times 2. Look at the moles of chloride ions in the 25 milliliter beaker. Okay, that'd be molarity times liters equals moles. Molarity is 0.2 times 0.025 equals 0.2 times 0.025 equals 0.005. All right, 0.005 moles. Without calculating the moles of the core ions in the 50 degree, what is it? Well, it's twice as big, so it's going to be 0.01 moles. Tripling the volume. The solution would triple the moles in the solution. Moles equals, okay, so it's going to be, well, this guy is tripling the volume of the solution. Okay, so we're going to take our original guy, which is 25 milliliters. This is my moles in the 25, so I'm going to go down here and say for a 75 milliliter beaker, 3 times that would be 0.015 moles. Just linear proportions. Okay, and away we go. Thank you very much.